let's talk about one-sided hypothesis testing. Here we can compare the mean of a sample with a number. So before we talked about the candy bar 6 gram example, so we would like to compare mean with 6. So mu naught here is 6, and if it is less than, so it's like, again, I don't need to divide alpha by 2. If I'm comparing two brands, let's say battery lives of two any companies, right, then I would be using two sample t-test. Okay, so here are the 20 data points for, let's say, battery lives, and I am interested in knowing that whether if mu naught is 27 months or not, like whether this particular battery brand is giving me 27 months life or not. So I have a few readings for that, um, 20 readings. So T19 and alpha is 5%. I don't need to divide it by 20%. If I'm checking both sides, let's say if it is not equal to 27, greater side and less than, then I need to divide alpha by 2. So here is 5% and 95%. Okay. If it was greater only or less than, then we would have written T19 point like 10 or 90%. Okay. Alpha value is already mentioned, which is 10%. Variance is calculated x bar, which is my sample mean. It's already given, or you can calculate it very easily. So T naught, how to calculate T naught? X bar minus 27, which is mu naught, divided by standard deviation divided by sample size. So this value comes out to be 2.43, and when you go to the table, lower bound and upper bound are minus 1.73 and 1.73. So this value is way greater than my upper bound, so it's in the rejection region. So we can say, okay, we are basically rejecting null hypothesis. So if population variance is known, use t-test. If population variance is unknown, right, remember, you can use t-test. If it is known, then you can deploy z-test. If sample size is greater than 30, then use z-test. But if sample size is less than 30, then it's you can use t-test. So, but if my sample size is very high, let's say 20,000 or 80,000, 90,000, then it doesn't matter, because uh, for a very high or large sample size, the t distribution basically converges to standard normal distribution. Formulation is very identical to that of a t-test here, and the same concept is being deployed. So again, one-sided z-test, the same formula which we deployed in t-test, the same concept. Okay, Here I just want to show you that if I'm what's happening if I'm increasing. So the for point 0.05, right, the cutoff points are given, which are plus 1.64 for z test here. And now let's just check the t table. So when my degree of freedom is 1, mean my sample size is 2, the cutoff region here or value is 6.314. This value is dropping until, let's say, in this particular scenario. So when my sample size is 121, so it's 1658. Before, initially, when my sample uh, my degrees of freedom was only like 1, right, the value was around 6, and it's 120, so 1.65. When it is infinite, 1.645, which is exactly equal to this value. So if what my point is that if my sample size is very high, that doesn't matter. But for small sample sizes, let's say n is smaller than 30, then you can use t-test. We have variance hypothesis testing also, because variance is a point estimator, and we could like test variance of two samples or test um, variance of one sample with some number. So formulations are given in class slides, just go through it. So this is it about hypothesis testing. Our next lecture will be about queuing and simulation in Excel. Okay, thank you.